Hi, welcome to lecture 5.4 covering dividing polynomials. Okay, so we're going to start our discussion with division of polynomials by actually going back to just long division with integers. So let's remind ourselves of the algorithm that is used when you just divide numbers. And that will give us insight as to how to go about dividing polynomials. So here we go. If I'm looking at 178 divided by 3, the first thing I do is start with estimation, and I ask myself the question, what do I have to multiply by 3 to make my very first digit there 1? And we know that 3 doesn't divide 1 equally unless you want to end up with a fraction. So I need to move to asking that same question about the first 2 digits put together. So how many times does 3 go into 17? And we decide that the answer to that question is actually 5. Now, I want to put that 5 in the tens column because I had to use the entire value 17 to begin my estimation. So my first step is to estimate. My second step is to multiply down. So 5 times 3 is 15. And then I'm going to subtract. 17 minus 15 is 2. And then I bring down. And then I start the process over until I'm left with nothing, or if I wanted to, or I may be left with a remainder. So I may be left with 0, I may be left with a remainder, or I could, if I have a remainder, I could add a decimal point and add zeros and continue this process for however long the number goes to, or until I wanted to stop if it's irrational and just keeps going. So now I'm asking, what do I need to multiply 3 by to make 28? And I can actually fit 9 3s into 28 because 9 times 3 is 27. And here I have a remainder of 1. So here's a blast from the past, R1. Probably haven't done that since elementary school. But here's the most important thing, besides remembering the process of long division. Here's the most important thing that we get from doing this division. Look, what it actually means. What this means is that 178 is equal to my divisor, 3, times my quotient, 59, plus my remainder of 1. So this is my dividend. This is my divisor. And this is my quotient. And this is my remainder. Now, I could write this a different way. This is the same thing as 178 is equal to my quotient times my divisor I'm sorry, I wrote that wrong. My divisor times my quotient plus my remainder over my divisor, 59 1/3. That's my remainder over my divisor to get that form of it. So if you grabbed your calculator, I've got my calculator right here, and you did 3 times 59, that's 177 plus 1 is 178. So that checks out with the first way we have it written. And then if I do 3 times 59 and 1/3, let me go back and put some parentheses here. 59 plus 1/3. I get 178 as well. So both of these interpretations are correct. And this is the one I want you to focus on, because this is the one that's going to be very important to us as we begin looking at polynomials and dividing them. And before we get into this, the reason that we're even learning to divide polynomials is because this is how you pull out factors. For example, if I look at my numerical example up here, I know that neither 3 nor 59 are factors of 178 because I have a remainder. So like if I have 6 divided by 2, that's just 3 with no remainder. 3 and 2 are both factors of 6. But if I have 7 divided by 2, that's 3 and 1/2, remainder over divisor. Neither of these, because I had a remainder, are factors of 7, and we know that to be true because 7's prime. So that's the value of all of this to us, because while we're learning to graph these polynomial functions, we know that the factors, the linear factors that come out, produce roots or x-intercepts for us. So when we don't know how to factor something, if we know one of the zeros, we can use that to pull other factors out of the polynomial itself. So that is the value of knowing how to do this. The good thing is that with polynomial division, it's no different in its steps from just dividing good old numbers. You just have to be a little more clever about thinking about it. So our first step with dividing polynomials is to estimate. And I'm going to tell you to focus on first terms. In other words, here's the first term of my divisor. Here's the first term of my dividend. And that's what I'm going to be focusing on right now. So I asked myself the same question that I asked myself in the numerical example. What would I need to multiply x by to get 2x cubed? Well, I would have to multiply by 2x squared, because 2x squared times x is 2x cubed. It's going to go in the x square column, just like you have to keep place value with your numerical division. So I would have to multiply by 2x squared. Second step, multiply down. So let me get a different color to show this. I've got to multiply by both of the terms in my divisor. 2x squared times x gives me 2x cubed. 2x squared times 2 is positive 4x squared. You're going to subtract. However, you never subtract polynomials. What you actually do is you distribute that negative and you add with the opposite polynomial. So you're not ever going to see anybody write out the subtraction of the polynomial like this. What you're going to see them do is just change the signs of their terms, because that's what the opposite polynomial is. It's the one that you can add to whatever polynomial you have and get 0. So this becomes a negative 2x cubed, and this becomes a negative 4x squared. because I'm subtracting that polynomial. And combine down. Okay, so 2x cubed and negative 2x cubed go away. You wanted that to happen. You're trying to whittle this polynomial down smaller and smaller. And when I combine negative 3x squared with negative 4x squared, I get negative 7x squared. My next step is to bring down. I'm just going to color code this. Bring down. All right, and I'm bringing down a positive 4x. Same thing here. Repeat as many times needed until you either end up with a remainder or no remainder. There's no more columns left to bring down. So I'm back focusing on first terms. What do I have to multiply x by to make negative 7x squared? That is negative 7x. Multiply back down here and here. So negative 7x times x is negative 7x squared. And negative 7x times 2 is negative 14x. Change my sign because I'm subtracting. They both become positive. And combine them down. Those go away. 4x and 14x make 18 x's. And now I'm ready to bring down. My last bring down here, and that adds a term of positive 5. Now, the last time through, I'm once again focusing on first terms. What do I need to multiply x by to make 18x? And that is positive 18. 18 times x is 18x. 18 times 2 is positive 36. I change my signs because I'm subtracting. And I end up with a remainder of, looks like negative 31. So, this is what this tells you, and this is why I spent time on the numerical example pointing this out. The original polynomial, your dividend that you started out with, is equal to your divisor, x plus 2, times your quotient, 2x squared minus 7x plus 18, plus your remainder of negative 31. And you could just write that minus 31. And you will find, let me take a picture of that answer and prove to you that it multiplies back out. Let me give myself a new page here. So if I was skeptical and wanted to check and see, does that really work out that way? Did I really just figure that out? You did. Watch this. If I start by multiplying x plus 2 times 2x squared minus 7x plus 18, and then subtract the 31 after I do that distribution, I should end up with the polynomial I started out with, the dividend. So I'm going to multiply here, here, and here, and I'm going to come back and go here, here, and here. So x times 2x squared is 2x cubed. X times 7x is negative 7x squared. X times 18 is positive 18x. 2 times 2x squared is positive 4x squared. 2 times negative 7x is negative 14x. And 2 times 18 is positive 36. And then I have a negative 31 to combine there. So 2x cubed. I have a negative 7x squared and a positive 4x squared, which gives me a negative 3x squared. I have an 18x and a negative 14x, which gives me a positive 4x. And then 36 and negative 31 make positive 5. That's exactly what you began with. It works. Okay, so a general note about the division algorithm. So this is just stating that your dividend polynomial, which is f of x, is equal to a non-zero divisor, and that divisor is in the form of, and we'll learn more about this in a moment, x minus c. It's some linear factor multiplied by your quotient polynomial, q of x, plus your remainder polynomial, r of x. Okay, so this down here are just the steps that I've already pointed out. You set up your division, determine your first terms, multiply, subtract, bring down, repeat until you're all the way through it. Let's give a couple of them a try. So the top just has the steps again for reference. All right, so in this one, we are dividing the polynomial 5x squared plus 3x minus 2 by x plus 1. So my first step is to focus on first term. What do I need to multiply x by to make 5x squared? That is positive 5x. Notice it's in the x column. I'm now ready to multiply back down. 5x times x is 5x squared, and 5x times 1 is positive 5x. I change my signs. This is negative and negative. Those are opposites and create 0, and 3x and negative 5x make negative 2x. And now I'm ready to bring down, and that is a negative 2. And I'm ready once again to focus on first terms. What do I need to multiply x by to make negative 2x? That is negative 2. Negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. Change my signs. And they both zero out. I have no remainder. What this means is that the factored form of 5x squared plus 3x minus 2 is equal to 5x minus 2 times x plus 1. Those are factors of that polynomial because I had no remainder. Okay, let's move to the next one. 4x plus 5 into 16x cubed minus 12x squared plus 20x minus 3. 4x would need to be multiplied by 4x squared to make 16x cubed. So I was focusing on my first terms there. And now I'm ready to multiply back down. 4x squared times 4x is 16x cubed. And 4x squared times 5 is positive 20x squared. I need to change my signs. And combine down. 16x squared and negative 16x squared zero out. Cubed, negative 12x squared and negative 20x squared make negative 32x squared. I'm ready to bring down. And I'm bringing down a positive 20x. That's an x, goodness. There we go. I'm ready once again to focus on first terms. What do I need to multiply 4x by to make negative 32x squared? That is negative 8x. Negative 8x times 4x is negative 32x squared. And negative 8x times 5 is negative 40x. Change my signs. And combine down. 20x and 40x make 60x. And I am ready to bring down. 60x minus 3. Once again, for the last time, first terms, what do I need to multiply 4x by to make 60x? Positive 15. 15 times 4x squared is 60x, and 15 times 5 is positive 75. Change my sign. And combine down. And I get negative 78. Okay, so the question, oh, no, this wasn't a question. It just said divide. So what this means is that my original polynomial, f of x, my dividend, is equal to my divisor, 4x plus 5, times my quotient, 4x squared minus 8x plus 15, minus my remainder. Well, plus my remainder, which is negative 78, so that makes it minus 78. Okay, so now you'll be pleased to know that there's a quicker way to do all of this. But we have to know how to do long division to understand synthetic division. So this is, that's not the problem we just did, is it? No. Okay, so here's a long division problem that we did at the very beginning. So this is the first one we did. And they had that written wrong. I took that screenshot. That should be 7x. They may have a typo there. I'll have to turn that into the book. This should be negative 7x. Yeah, they have the 7 there. Okay. So if you notice, you can really ignore the variable terms. Not the variable terms, but the variables on the terms, and just pay attention to the coefficients. So if I went here and I whited out all of my variables, you would see that the pattern, or what's really going on that's important in here, is what's happening with the coefficients. So off to the right here, all I have are the coefficients in my division process here. Now, since you don't really need the variable part of the terms to actually do long division, you just need to know what place they're sitting in. You can put them aside and use what we call synthetic division. So I'm going to do this same exact problem using synthetic division. Don't worry if you understand it this first time through or not, because I haven't even shown you the steps. I will speak the steps as I go through them, then we'll look at the steps, and then we'll practice a few more examples. So my first step, and notice I just have the coefficients of my dividend on the inside of my house. And notice this is a negative 2 on the outside. That's because it came from a factor of x plus 2. Let me show you. I covered up. Okay, so there we go. You can see that this came from a factor of x plus 2. If we were using the zero product property, that'd be x plus 2 equals 0, so x is negative 2. When you run it through synthetic division, that's what you use. We call that value C. You use your C value to do synthetic division. So Here we go. I'm going to bring down 2. I'm going to multiply with C, which is -2. So -2 times 2 is -4. Write my result in the next column. Combine down, which is -7. Multiply with C. Write my result. Combine down. Multiply with C. Write my result. Combine down. Your last value is always your remainder with synthetic division. Notice, let me get a different color to point this out. I started with an x cubed. Let me just uncover all these variables here. I started with an x cubed. I have taken out a factor of x, and I end up with an x squared quotient. So you do have to be aware of that with synthetic division since you're not seeing any of your variables. So I know I started with x cubed. I took out a factor of x here. I am left with 2x squared minus 7x plus 18 with a remainder of 31. Same thing that you get with long division, just much quicker and much more compact. That's synthetic division. So x minus k, that's that c value I was telling you about. They're calling it k there. So you're going to use k as your divisor. So notice if it was an x plus something factor, you'd need to use the negative of that because it's x minus negative to make that plus. So you write your k divisor, write your coefficients inside the house, bring down, multiply with k, write it in the next column, add down or combine down, multiply with k, write in the next column, and you repeat until you're done. Your last digit is your remainder. Okay? Use synthetic division to divide 5x squared minus 3x minus 36 by x minus 3. A factor of x minus 3 is actually a k value of positive 3. So 3, I'm just going to write the coefficients, 5, negative 3, negative 36. Bring down, multiply with k, write my result, combine down, multiply with k, write my result, combine down, no remainder. Here's what this means. 5x squared minus 3x minus 36 is equal to the factor I started out with, x minus 3, times k. I started with an x squared. I took a factor of x out. So what I'm left with is an 5x plus 12. 5x plus 12. X minus 3 is a factor of the polynomial. 5x plus 12 is a factor of the polynomial because I do not have a remainder. So both of those are factors. Okay? Now look at this next one. Notice you are missing an x squared term. You have 0 x squares. When you are doing long division or synthetic division, you have to put a 0 placeholder wherever it may be missing. Like if it jumps over a place value, so to speak, with your variables, then you've got to put a placeholder in there because we need all those spaces. All right, so x minus 2, that gives me a k value of 2. I'm going to put my coefficient. That's 3x to the 4th minus 6x cubed. I have 0 x squares minus 5x and then a positive 10. All right, bring down, multiply with k, write my result, combine 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 down. I have a 0 remainder. Now, I started with a quartic, or a polynomial raised to the 4th power. I took out a factor of x, and I'm left with an x cubed. I have 0x squares, 0 x's minus 5. Both the divisor and the quotient are factors of the polynomial, so this tells me 3x to the 4th minus 6x cubed minus 5x plus 10 is equal to x minus 2 times 3x cubed minus 5. And I have no remainder, so both of those are factors. Okay, so we have the volume of a rectangle. Let me draw a rectangular solid. I have a rectangular solid here. I know it's a solid because I have volume, so I have length, width, and height. That's pretty bad, but use your imagination. And I am told the length of the solid is given by 3x, and the width is given by x minus 2, and it says find the height of the solid. Okay. Well, I know that volume is equal to length times width times height. And I know that my volume is given by 3x to the 4th minus 3x cubed minus 33x squared plus 54x. And I know that that has to equal 3x times x minus 2 times some height, and they told you to call the height t for some reason. I don't know why they renamed height t, but they told you to call it t. I've used x's here, so I'm just going to say, I'm just going to leave it as I'll call it t like they did. I'll just make it a different color. I don't like that, but there we go. Some height t. So what I can do here, because all of these, the length, width, and the height are being multiplied to create that polynomial, if I can divide out the length and the width, then I'll be left with my height. So that's the only other thing that multiplied together to make that. First thing I'm going to do is divide everything by my 3x. I'm going to take that common factor of 3x out, because then I'll be left with a linear factor here that I can use synthetic division with. Okay, so 3x to the 4th divided by 3x leaves me with x cubed. Negative 3x cubed divided by 3x leaves me with negative x squared. Negative 33x squared divided by 3x leaves me with negative 11x. And positive 54 x divided by 3x leaves me with positive 18. So I've divided that 3x off of both sides, and now I'm left with x minus 2 times some height that I'm trying to figure out, t. Okay, so now if I divide this x minus 2 out of, or off of both sides, so it's going to come out of that polynomial, what I'll be left with is my t height. So I'm going to use synthetic division for this. I have a k value of 2. I have coefficients of 1, negative 11, and positive 18. Bring down, multiply, combine down, multiply, combine down, multiply, combine down, remainder of 0. I started with a cubic, took a factor of x out. What that leaves me with is an x squared plus x minus 9. So my height t is equal to x squared plus x minus 9. That's it. Okay, we can also use fractions in synthetic division. Now, these aren't hard, so don't hyperventilate. They're nice, neat fractions to work with, but you can have fractions, and I'll show you where those fractions come from real quick before I actually jump into the synthetic division. If I have x minus 1/2, remember my zero product property said that that came from there. So if I want to get rid of that fraction, I clear it by multiplying by my common denominator, and that denominator multiplies to all of my terms. So that came from a linear factor of 2x minus 1 equals 0. And I'll just show you how I know that. So when I divide, I'm going to be, in synthetic division, I'm going to be using positive 1/2, which is what I get when I actually use the zero product property and solve. So I add 1, and that's 2x equals 1, divide by 2. So now my k value is 1/2. So that's where that came from. So that it is possible to have to run fractions through the synthetic division process. So let's go ahead and look at that. So I have a k value of 1/2. I have coefficients of 2, negative 1. I skipped over x squared, so I need a 0 there. 2 and negative 1. Bring down, multiply with k. Half of 2 is 1. Write it in the other column. Combine down, half of 0, 0. Combine down, half of 0, 0. Combine down. Half of 2 is 1, combine down, I get a 0 remainder. What this says is 2x to the 4th minus x cubed plus 2x minus 1 is equal to my divisor, x minus 1/2, times, which I could also write that divisor as 2x minus 1, remember, times my quotient. I started with an x to the 4th. I took one factor of x out, so that leaves me with an x cubed, 0x squared, 0 x's, and a positive 2. So that leaves me with 2x cubed plus 2. All right. Same thing with x plus 1/3. Now, it's a plus. Remember, that's minus a negative. So my k value is negative 1/3. And I'm running that through 3, 1. I skipped over x squared again, negative 3 and 1. Combine down, multiply with k. So negative 1/3 of 3 is negative 1. Combine down, 0. Combine down, 0, negative 3. Negative 3 times negative 1/3 is positive 1. And I have a remainder of 2 this time. So what this says is that my original function, f of x, or my dividend, is equal to x plus 1/3 times, okay, let's figure out what we have here. We started with a 4th. We took out one factor of x, so that's an x cubed, x squared, x minus 3. So I'm left with 3x cubed minus 3. That's it. Oh, plus 2 as my remainder. Okay, and finally, this is our last slide. You can actually do synthetic division with imaginary numbers. All right, hold on to your britches here. It's not as bad as it looks. So I have x plus 1. So I'm going to go ahead and put my coefficients here. There's a 1x and a positive 1 being divided by x minus I. So my k value is actually I. It's the same exact process, so don't freak out. You bring down, multiply with k, write my result, combine, that is add, down. So I'm left with an 1 plus I as my remainder here. So what I have happening here is I have a my x plus 1 being equal to my divisor, x minus I, times 1, plus my remainder of I plus 1. I'm sorry, 1 plus I. And let me check that real quick and make sure I've written that correctly. Okay, so when you write this factored form out, you always put your remainder over your divisor, which in this case is x minus I. The question was just to give the quotient, not the entire factored form. So my quotient ends up being 1 plus my remainder over my divisor. So there's your quotient. All right, let's look at this next one. And this is the last one for this. Okay, so I still have a k value of I, and this time I have an x squared with an understood 1. I have 0 x's and 1. Bring down, multiply, combine down, multiply. I times I is I squared, but I squared equals -1. So 1 times -1 is 0, so I have a 0 remainder. Okay, what this says is I have a factor of 1x plus I there. So this says that my quotient, the part they want you to write, is just x plus I. That's my quotient. But what it means is that my original function, x squared plus 1, is equal to x minus I, my divisor, times x plus I, my quotient, because I have no remainder. And that's all I've got for you. I hope this was helpful.